So hi friends, this is the Leetcode challenge for 2nd July 2023 and let us see what is the question. The question is maximum number of achievable transfer. So first of all read this question and we will try to solve this question. Okay, so we have n buildings. Initially we have n buildings 0 to n minus 1. So basically we have n buildings 0 to n minus 1. Okay, each building has number of employees in it. Okay, so we have n buildings 0 to n minus 1 and there are employees in each building. Okay, it's transfer season and some employees want to change the building they reside in. Basically transfer season is going on and some employees are willing to change their buildings from any building to any other building. Like you can see that here X employee is willing to change its building from 0 to 1. Y is willing to change from 0 to 1. B is willing to change from 1 to 0. So this is all how employees are willing to change their building. So you are given an array request where request of I is equal to from I comma to I. Okay, represents employee request to transfer from building from I comma to I. So we have this request array and each element of this request array represents a from building to building. So which means employee is willing to change his building from 0 to 1 in this case. Okay, so let us see the diagrammatic representation of this question. Basically we have total of 5 buildings here for the case 1. You can see that there are 5 buildings for the case 1 and there are 6 requests. Okay, so basically what it is, uh, what they have told us that employees are changing their building. Okay, so let us say these are the requests. So if this request is passed, okay, the first when the first request is passed, okay, so the employee from 0th building will go to first building. So from 0 to 1, so employee is going from 0 to 1. So this is okay. When second request is passed, employee is going from first to 0. So this is the case. Okay, so let us see what they have asked further. All buildings are full, so a list of requests is achievable only if each building the net change in employee transfer is 0. So they have given us a condition that each building is full. Okay, each building is full. There is no extra space for any another employee, which means that you cannot add total of one employee extra in any of the building. Okay, which means that if you are adding any employee in any of the building, you have to remove the same number of employee from that building. So let us see the requests. So first of all, we will see, we will take a case that we are passing first two requests. So what will happen? Uh, Employee will go from 0 to 1. So what will be the net change for this case? You can see that the net change in 0th building will be what it will be minus 1 and for the first building it will be plus 1. Okay, and when the second request is pulled, what it will happen? Employee is going from 1 to 0. Employee is going from 1 to 0. So it means that the total number of employee in 0 is added. Okay, so difference will be increased by 1 and here for the building 1 the difference will be decreased by 1. So you can see that overall change in building 0 is nothing but 0 and same in building 1. Okay, so is this case valid for uh, our question? Yeah, it is valid because here total number of total number of employee added and removed is same, which means there is no difference in total number of employees before and after the request, and same in the building one. So this case is valid. Okay, return the maximum number of achievable requests. So in this case we have two requests. Okay, we have passed two requests, so we have to maximize this number of requests. So let us see what happens when we pass first 5 requests. Okay, so when we pass first 5 requests, what will happen? So 0 to 1 again, we have passed first and second request. So corresponding to this, the answer is with us and we are moving forward. uh, when we pass the third request, what will happen? When we pass the third request, employee is going from 0 to 1 again. So what will happen? So what will happen is that here employee will be decreased in 0th building and it will be increased in building 1 by 1. Okay. When the fourth request is passed, it means 1 to 2. So it means 1 to 2. So what will happen? Employee will be decreased in 1 and increased in building 2. So for building 1, we will write -1 here, and for building 2 what we will do, we will add +1 here. When the fifth request is passed, you can see that employee is going from 2 to 0. So for this request, employee is going from 2 to 0. So for this case, what will happen? For this case, here for the building 2, -1 will be there, which means total difference of -1 again, and here it will be of +1. So you can see the overall differences. In the 0th building is 0, in first building it is again 0, in second building it is again 0. So this case is valid and the total number of requests passed is 5. So this is another maximum value. So let us see what happens if we want to check for the 6th request. If we pass 6 requests, so what will happen? If we pass the 6 request, the value corresponding to the 3 value corresponding to third building will be -1 and for the fourth it will be +1. So there are changes in third and fourth buildings, so this case is not valid. So the answer will be 5. So basically we have to iterate over all the possible combinations of requests and check the maximum value corresponding to the valid cases. Okay, so let us try to solve, let us think about how can we iterate over all the possible cases. So to iterate over all possible cases, we have to first find the total number of possible cases. So you can see that for each case, for each request, we have two possible things with us, that we can pass it or we cannot pass it. For 0th request, we can pass it, we cannot pass it. For the first request, we have again two choices, we can pass it, we cannot pass it. So you can see that for each of the requests, we have two choices, and those choices are we can pass the request or we cannot pass the request. So for this case, we have total of 6 requests. So the total number of combinations will be 2 to the power 6, which is 32. And in general, if there are n1 number of requests, if there are n1 number of requests, the answer will be power of 2 comma n. It means 2 to the power n1. So there are 2 to the power n1 possible cases for n1 requests. So in this case, we have 6 requests. We have to iterate over all 32 requests. Okay. So how can we solve this? So let us see what if we are on 0th combination. What if when we are on 0th combination? So let us, I am trying to solve this question. I am going to tell you the way how can we use bit masking here and find all the possible combinations. So for the 0th combination, you have to do one thing, that you have to write bitwise representation of 0 in a bit string of length n1. So the bit string of length n1 is nothing but 0 0 0 0 0 0 for 0th combination. It means when I is equal to 0, I is equal to 0, it means 0th combination. Okay, it is 0th combination. So this is the bitwise representation of I is equal to 0 in bit string of size 6. So basically here n1 is equal to 6. So here n1 is equal to 6. So the size will be 6. So how this thing is going to help us? You can see that here there are 6 requests and the size of this bit string is also 6. So if the if a particular character, if the ith character of this bit string is 0, then the ith request will not pass. If the ith character is 1, then the ith request will pass. So I will write here, if the ith character of bit string is 0, so what will happen? Then ith request is not passed. If it is 1, then ith request is passed. So for this case, there is for each I from 0 to 5, you can see that there is 0. So it means this is 0. This is 0. 0 means it is not going to pass. This is also 0, which means this case is also not going to pass. This request is not going to pass. And similarly all other. So you can see that no request is going to pass. If no request is going to pass, you are not going to change anything. So this is valid case, but we have to maximize this. Okay, so let us think about some more cases like we have done for the 0th combination. Let us think about the 30th combination. What will be the 30th combination? So when I is equal to 30, so 30th combination. So 30th combination. So for 30th combination, what will be the bitwise representation? 111 110. So this is the 30th combination. Okay. So for this case, first five requests are going to pass. So first five are going to pass, which means this is one, 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 and the last one is 0. So first five are going to pass and the last one is not going to pass. And we have already seen when the first five requests are passed, the answer is valid. Okay. So in this way we have going to choose uh, we are going to iterate over all possible combinations and we will check whether the particular combination works better or not, and if it works better we will maximize the size, sorry, we will maximize the number of uh, requests passed in each case. So in this case number of 1 is 5, so number of requests passed will be 5, so this will be the answer. Okay, so let us dive into the code. How can we write the code? So I have some of the variable with me. Int maxi is equal to 0, which represents the maximum number of requests passed. So I am using short form here. Okay, and here I have a variable int n1, which means which is nothing but requests array size. So it is nothing but total number of requests we have. So we have total of n1 requests. So if we have total of n1 requests, so total number of possible combinations, let's say m, is nothing but 2 to the power n1. So this is total combination of requests. Okay. So we are going to iterate over each combination. So for each combination, I am using for loop for int I is equal to 0 to m, and for each I we will create a bit string of size n1. So we have to create a bit string of size n1. So basically there is a issue with C++ that we cannot create a bit string of size of variable size, which means basically the format of creating the bit string is I'm going to show that here we have a string bit, and I want to create a bit string of size let's say here n1. So the code will be bit set of size n1 uh, for I dots to string. The problem with C++ is that we cannot pass here a variable. We have to pass a particular integer here. So in constant you can see that the maximum value of n1 number of requests is 16. So first we will get the bit string of size 16, and then we will um, choose some subset of that string, some substring and of size n1, and we will have our bit string of size n1. So basically I'm going to show how it works, what I've done here. So basically talking about this case when I is equal to 30. So okay, for I is equal to 30. So basically our answer is not, our bit string is nothing but 111110. But because we cannot create a bit string of size 6, okay, we have to create a bit string of size 16. So first we will create a bit string of size 16. So bit string of size 16 will be nothing but 000 000 000 and one more 0, total 10 zeros and 6 bit string like this. Okay, 111110. So this is also 30. So because we cannot create a bit string of a variable size, we have denoted an integer here. We have to fix the size. Okay, so here it is 16 and this is of total 16. The length of this string is 16, but we are willing to choose only n1 strings. Okay, n1 characters. So last n1 characters are useful and rest are not useful. So we will choose this subset. We will take this subset of our bit string of size 16 and we will be using this. So uh, we have done for 16 because we can't do for variable n1. Okay, so we cannot do for variable n1. So basically we have to choose for last n1 characters. So last n1 characters of this bit string has to be chosen. So this is basically nothing but 16 minus n1. So this index is nothing but 16 minus n1. Okay, so this index is nothing but 16 minus n1. So from 16 minus n1 to the last, we have to choose the substring. Okay, so we have another string of let's say p, and it is nothing but substring of bit with the index, and here index is nothing but 16 minus. Okay, so this is what our t is. Now what we are going to do, uh, as I told here that if the ith character of this bit string is 0, then we will pass the request, otherwise we will not pass the request. So we will do the thing I am going to write here. If okay, so for this I am going to create a vector of int for difference diff of bit. Okay, so basically size of this will be n and it will be initialized by 0. So basically it is showing, this will show difference in number of employee in each building. Okay, so this is used to show that. Okay, and I will now iterate over this n1 characters of the string p, and if the character is 0, what we'll do, we will pass the request, otherwise we will not pass the request. So basically the size of that p is nothing but n1. So for int j is equal to 0 comma j less than n1 comma j plus plus. So if the jth character is 0, so request is let us say if the jth character is 1, request is passed. Okay, so when request is passed, what will happen, we have two indices with us. So uh, int a is equal to request of j dot 0. So if we are going to choose this request, so let us say we are on uh, int j is equal to, so if j is equal to 2, we have to choose this request. Okay, and also one thing also, if p of j is equal to 1, when this is 1, then and only then we are going to choose any request. Okay, otherwise we will not choose the request. So for, let us say p of j is equal to 1, so here j is equal to 2, let us assume j is equal to 2. So if p of j is 1, then we will choose the jth request. Okay, so jth request is 0 1. So for chest request I have two integers. Int a is the from part, so basically a is nothing but from, and int 2 is nothing but request of j comma 1. So here our from and to are, and we are going to decrease the value of difference built in from by 1, and diff of build of 2 will be increased. Okay, so this is done, and basically after performing all, after iterating all through all the characters of p, we have to check whether each and every element of this diff build is 0 or not. So for this I am going to pass a bool okay is equal to 1. So for auto ele of this diff build, what we will do, if ele is not equal to 0, then OK is 0, and we have to break our loop, which means there is a difference in a particular building, which is not our case. So we will break here and change the value of OK. And if OK is not changed, means our case is valid, then what we will do, we will maximize our number of requests passed. So number for passing number of requests, we will write int count is equal to 0, which will count the number of requests passed. Okay, so here we have to also multiply, add one more thing, count plus plus, which means this request is passed. So we, so if our case is valid, what we'll do, we will maximize the value of maxi with count. Okay, and after that we are going to return this value. So let us check whether this will work or not. Yo, it is working. So let us move further for main cases. It is absolutely working. So you can see how it is working, that I am again going to explain. uh, we have to iterate over each cases, iterate over each possible combinations, and we have to, so we have iterated over, let's say we have iterated over 30th case, okay, 30th combination, and we have checked whether this 30th combination is valid or not, and it is valid, and the answer corresponding to the 30th combination is nothing but 5. Okay, so this case is valid, and the answer corresponding to this is 5, and we are going to maximize this. So in this way you can see that how this question is solved using bit string and bit masking and all. And I hope this explanation will be helpful for you, my solution is helpful for you. I hope you understand the question, and now you are able to, you can solve this question by your own. So if you like my video, you can, if you like my solution, you can like my video, you can subscribe my channel, and once again thank you.